Hello everyone, my name is Neha Thakur. Today I am going to discuss about Nmos fabrication. So first of all, you should know what is Nmos. Nmos is N-channel MOSFET, and N-channel MOSFET means the channel area that is formed between the source and drain contains electrons as the charge carrier. So for its fabrication, following steps are required. So for any fabrication, be it NMOS, PMOS, CMOS, it always starts from the substrate. So what is the necessity of a substrate? As if you want to build anything, be it a building or even a drawing or a circuit in your electronics lab, so you need some base to make it. Like you will be needing a PCB board for making a electronic circuit. For making a painting, you will be needing a canvas. For making a building, you will be needing some ground level area, so on that only you can build something. Similarly, for fabrication as well, the transistors, they need some base on which it can be developed. So substrate is the area or the base onto which the fabrication can be done. It is the silicon substrate, and for NMOS, the substrate type used is P-type silicon. Why is that so? Because the voltage supply used for NMOS is positive, so then it should be connected to ground. The substrate should be connected to ground, because here the gate voltage is connected to positive VG, so it should be positive and negative. So in order to make it reverse bias, it should be P-type substrate, so that the mobility of electrons is maximum if the substrate is of P-type. In the second step, a thick oxide SiO2 layer is deposited all over the substrate. Here thick oxide SiO2 layer, why it is called as? Because the thickness is from 5 to 10 micrometer, and this thick oxide is also known as field oxide layer. The field oxide layer is also known as thick oxide layer, and the thickness is 5 to 10 micrometer. Later on, we want the whole layer is deposited with photoresist. So photoresist is light sensitive, acid resistant organic polymer. So basically, what is the requirement? Requirement is that the SiO2 layer is needed only on the source and drain terminal. Thick oxide layer has nothing to do with the gate area. This is all known that NMOS has 3 terminals: source, gate and drain. So the thick oxide layer is used for implementing only source and drain. That means the gate area should not be containing the thick oxide layer. So the thick oxide layer, to remove it from the gate area, a photoresist will be required. Photoresist is nothing but a light sensitive, acid resistant organic polymer. That means it changes its properties according to the light. It is light sensitive. Whenever a word photo comes, it means light sensitive. Like photodiodes are there, so what do? When light falls upon them, then the current conduction takes place. So in electronics, whenever it is the word photo comes along with some parameter, then it means it is sensitive to light. Its working depends upon the light. So here it depends upon the UV light. So photoresist, it changes its solubility from by the application of UV light. So there are 2 types of positive photoresist, positive and negative. So positive photoresist converts insoluble material to soluble. So see, what happens is, there are 2 type of people. One is having positive approach, and another one is negative approach. So the positive thinking people, they will always think all the impossible things are even possible. But the negative people who thinks negatively, they will assume all the possible things are even impossible. So same is with the photoresist. You can learn like this. Positive photoresist, it converts insoluble material to soluble. Negative photoresist, it converts soluble to insoluble. So here, according to the requirement, you can use any type of photoresist, but generally positive photoresist is preferred over negative photoresist because of its high resolution. So here a UV light, a mask is created. See, because you do not want SiO2 to be removed from the source and drain. We want only this much gate area to be removed. On source and drain, SiO2 is required. That is why masking is done. What is this mask? It will protect this UV light to fall upon the layers. On the thick SiO2 layer, it will prevent falling upon it. So when UV light is exposed all over it, then this masking area, it will be protected, and then on the remaining portion the UV light will fall down and this area will be exposed photoresist and it will become soluble. As positive photoresist is being used, then this insoluble material will be converted into soluble. So soluble means what? The material, it will become soft in nature and remaining it will be hard. So the soft material, it can be removed easily by the help of HF acid, which is also known as dry etch technique. Etching is the technique which is used to remove the specific layer, or which is used to remove the deposited layer from the surface. So this is what then hardened photoresist, it remains over the SiO2 layer and later on it is also washed away. Then the final resulting layer is like this. So the requirement was the thick SiO2 layer is required only on the source and drain terminal. So next is a thin SiO2 layer is deposited over it. So thick SiO2 layer thickness is from 5 to 10 micrometer and thin oxide is almost 1/10 of the thick oxide. So basically this, if suppose this is 10 micrometer, then it will be around the measure 1 micrometer. Then thin oxide layer is deposited all over the surface. Over that polysilicon is deposited. So polysilicon is nothing but polycrystalline silicon. It is the type of silicon which has polycrystal nature. So this layer is also deposited over thin oxide layer. Now again the polysilicon layer is required only at the gate terminal. And so basically thick oxide is required only for the source and drain, and thin oxide is used for source, gate and drain, and polysilicon is used for the gate terminal. Then later on this polysilicon layer, because it is required only on the gate terminal, so it is etched away from the source and drain and it remains on the gate terminal. So actually for this also what will happen, again the same step will be done. A photoresist will be deposited all over the surface. A photoresist layer will be deposited all over the surface, and then again the masking will be done, and wherever the required polysilicon layer is there, so only that portion will be remaining, other portion it will get removed. So finally this figure will be obtained, and later on this thin oxide layer, it also gets etched away, and the thin oxide layer, it remains only on the source area, drain area and gate area. So this is the structure that is obtained after removal of the extra thin oxide layer. Now later on, as the three terminals, till now the three terminals are defined. This is source, this is drain and this is gate. Now because this is Nmos, till now MOSFET is defined, metal oxide semiconductor, and source, gate and drain are defined, but now we have to make it Nmos. So for making it Nmos, the channel should be of N type, so it will become N type when two N plus impurities are doped into it. So what is N plus? N plus basically means highly doped. It means highly doped. So highly doped, it means if suppose the value of concentration of N is 10 to the power 4 per centimeter cube, then N plus will be 10 to the power 6 per centimeter cube. The doping of concentration of impurities is higher, so N plus is doped for Nmos. What is the reason only N plus can be doped? Because for creating the N channel, source should be of N type and drain should also be of N type. Later on, an insulating layer is deposited all over the surface. What is the purpose of this insulating layer? Till now, see, because here we are seeing these pictures very big enough, okay, but actually when we talk about the channel length is in micrometers or nanometer. So you can imagine this much is the channel length. It is having the gap of almost 1 nanometer, so it will be very difficult in practical applications, or in the practical scenario it will be very difficult to differentiate between the source and drain region. So in order to overcome the drawback of overlapping of the layers, the insulating oxide, it can be deposited over the layer in order to differentiate between source and gate region and drain and gate region. So this insulating gate oxide, it is deposited all over the surface, and later on it is removed from the area. It remains only on the source, drain and gate. So now it can be seen the source, gate and drain area, they are insulated from each other. This is the source area, this is the gate, and this is the drain region. And later on, a metal layer, usually aluminium is used as a metal, it is deposited all over the surface. The reason metal layer is deposited, it is used for making the interconnections. When the fabrication, after the fabrication, stick diagrams and layouts, they will be studied. So in that also we will discuss that metals are basically used for interconnections between from one system to, or from one transistor to another, because these transistors, they are basically fabricated in the chip, and chip is containing even thousands and millions of transistors. So it is not possible that you are making only single transistor and it will be used as a standalone device. It will obviously be having a certain connections with other transistors as well. So metal layer, it is used for interconnection. And later on, this metal layer, it is also etched away, and the three terminals, source, gate and drain, these are defined. So from this fabrication, all the steps, what we understood is why metal oxide is also known as metal oxide semiconductor, because if we look upon the layer, so the topmost layer is of metal type, and these between layers, these are oxide, and the last layer is semiconductor. So that is why it is metal oxide semiconductor, because the topmost layer is metal, and then it is followed by the oxide, and then the last layer is semiconductor. So if you have any doubt in this topic, you can ask in the comment section, and please like, share and subscribe my channel, and look forward for other videos.